Hello geometry students, today we are going to do lines and segments that intersect circle. We're going to do some problems, practice problem. I'm covering Big Idea Math Student Journal 1 through 10, and afterwards I included some textbook problem too. So let's start. First question is here. We have been given question number 1 through 6 and a diagram on the right hand side. What we have to do, we have to find out the given indicated things, like name two radii. Here we have to name two radii in the given picture. When I look at it, I could see they just want us to give two radii. I'm just going to give all the possible radii. All right, so our first radii, I see this could be one radii, this is going to be other radii, and this is the third one. I could name all three. All right, so my answers would be AB, AD, and AF. They want us to name just two, but I'm just giving you all options so that in case if you want to just think about it. And let me just do the next problem. Now our next problem is name a chord. I have to name a chord. Chord is basically something which is starting from the circle, ending at the circle. So in this case, our chord would be, first one is CE. This is the first chord, CE. Second chord is DE. This is our second chord, starting from the circle and ending at the circle. And other one is, I could include, it's a DE is this one, and then other one is DF. I just marked there in a wrong order. So, but these three will be considered three chords. Okay, let's move to the next problem. So, question number 3 that says we have to name a diameter. So, diameter is a chord which always passes through the center. So, we just see one thing. So, that is going to be DF. All right, that's the diameter. So let me erase it and do the next problem. Now we have to do the secant. Secant is just kind of chord, but it's entering, means it's moving in both direction. It just crosses the circle. So when I look at it, I see just one chord here. It's a line which is like this. It has to, both ends should be coming out of the circle. So that's DE, and it's a line here. So my symbol will be changed. All right, so let me erase it, or do I need, or I could still use it. Okay, so let's move to the other one. Now I have to do what? I have to find a tangent. Tangent has to just touch at one point. So I see this is the line which is touching here, point B. So I can say line passing through point B. All right. Then our next question is, they want us to name the point of tangency, where it touches the circle. So this is the point of tangency. So here it touches the circle, so we can say point B. All right, so let's move to question number 2 that says tell how many, means we have to just count something, common tangents to the circle have and draw them. So if I have to find common tangents, like the tangent which is tangent to both. All right, in that case, if I'm just thinking, so if you want to do it on your own, just stop the video and think about it. Otherwise, you can continue. I can think about this one. This could be one tangent. And is there any other way I just draw it? No matter if I draw this way or any style, nothing is going to work. Like if I'm just drawing a tangent here, but this will be just to one, not going to work. So other could be this one. This is touching both circles. So I have how many? This is the first and this is the second. So how many tangents? We have 2 tangents. All right. So let's move to our next question, number 8, that is saying, tell whether each common tangent is identified in exercise 7 is internal or external. So you have to check about whether they're touching internally or externally. So when they touch internal, they connect the centers. Here they're not connecting the centers, so we see that they're just touching from outside. So they're going to be external. All right. Let's move to the next problem here. That is, let's move to the next one. This is the next problem, and here in this case, what do we have? We have been given question number 9 and 10, and we have to point D as the point of tangency. So this is the point of tangency. So this is going to be a tangent. All right, this is our tangent, and what we have to do, we have to find BD. I have to find this thing. I don't know how much is that. And I told you, whenever you don't know something, assign a variable. I'm going to assign it y. And if it is a tangent, if BD is a tangent, it means what? If it is a tangent, it means AD is perpendicular to BD. And how we can write that? We can write it by tangent line to circle theorem. We use that because this is going to be tangent only when this is 90 degree. If it is 90, now we have a right triangle. We can use Pythagorean theorem and apply that. So that is basically, that says leg square plus leg square is hypotenuse square. And we just plug it in, 5.5, or let me start with y square plus 5.5 square, and hypotenuse is 10, because this is our 2 legs and this is our hypotenuse. This is leg, and this is hypotenuse. All right, so let's plug it in and solve it. So when I solve it, I get y square is what? Sorry, this is 10 square minus 5.5 square, and square root of that is going to be y here. So I just take out, sorry, this is 5.5 square, so this is going to be y, and y is roughly equal to 8.4 units. I got my y, so I know this is going to be 8.4. Now let's see, move to the next question. Next question says C is also point of tangency. So this is point of tangency, so this is also a tangent. All right, and BC, they have given an expression for BC, that is 4x plus 6. They have given 4x plus 6, so let me just erase it here, this thing. All right, so now I know this is tangent and this is tangent, and let me highlight that. So this is tangent and this is tangent, and one of our theorems says that external tangent congruent theorem, we can use that. External tangent congruent theorem, that says that the external tangents, they from a point, they're going to be congruent. So they're going to be congruent, and I know they have given this is BC is 4x plus 6. If they're going to be congruent, I can set up an equation that BC is congruent to BD. All right, and after that, if I get it, I can write my equation, that's 4x plus 6 equal to 8.4, and I simplify it, solve it for x, that's going to be 2.4, subtract 6 from both sides and divide by 4, you get 0.6. So that's your 0.6. X is your 0.6. So I hope you get it. So let's move to next problem from textbook. So we're moving to next problem from textbook that says example 1, that is basically saying what we have to do. We have to identify special segments and line. So in that case, I have been given a picture. I have to find which one is best described: a radius, a chord, diameter, secant, and tangent. When I look at AC, this part, what it could be? It's going to be radius, because C is the center and A is the point on circle. Let's look at the second thing. If I'm talking, so we are done with AC. If I am to find AB, so AB is what? From here to here, passing through the center. So it has to be what? A diameter. All right, it's the longest chord. It's the longest chord for a circle. Then what is the next thing? DE. DE is what? This is DE. We see DE is touching where? It's touching here, just one point. So it is supposed to be a tangent ray, because it's contained in a line that intersects the circle in exactly one point. When it touches just one point, it's a tangent ray. If it touches more than one point, it becomes a secant. So let's move to the next one, AE. This is AE. AE is where, when I look at AE, AE is this one. So it's crossing the circle, touching the circle at this point and this point, 2 points. So that becomes a secant, because it is intersecting the circle in 2 points. All right. So let's move to the next question. When I move to the next question, it is this one, example 2. All right, example 2, drawing and identifying common tangents. We have to draw and identify whether it's external or internal common tangent, and how many tangents we can draw. So first case, when I look at it, feels like you can see here this case, you can see this one tangent, and this is the other tangent. So we have this is the first one, second one, and then because they're not touching there is a gap in middle here. This part in the middle has gap, so we can have another pair of tangents, 3 and 4. So this way we have total 4 common tangents. All right, because the gap is here, outside and inside. All right, so 4 common tangents here. Let's move to the next part. So blue is the external one. So this is the external, this is the external, and the red, because it's passing through inside, and so this is internal and this is internal, and you see it's intersecting the line segment joining the center. Now we have to look at the second one, this one. You can see there is the first and the second, both are passing from outside, touching from outside. So they're external. I'm using E for external, and they're just touching at one point. So I could say that this is going to be the third one, and that's going to be internal. So 3 common tangents. Let's look at the third case, C. When we have this one, this is just like your problem in your journal. So we see first tangent, common tangent, second, and both are touching from outside, so external. And I can find out how to draw anything here or here. It's really hard. I can't do anything. So this is no internal tangent in this case. I hope you get it. Let's move to question number 3. So question number 3, that's going to be verifying tangent to a circle. Is ST a tangent to circle P? So this is a way how you write the name of circle's name. Like you write triangle ABC, you just make a circle and a center and write the name of the center of that circle. So because the center is P here, so the name of the circle is circle P, like this. We have to verify if it is a tangent. So converse, if it is a tangent, we know if it is tangent, then it is supposed to be 90 degree. All right, so we can use the converse of Pythagorean, that if it is a tangent, then it should be, this statement should be true. All right, and because this is true, then, and you can verify it by calculating it. You will see both sides are same. In that case, the values are same, so it's a 90 degrees. So this is going to be perpendicular. The radius is perpendicular to the tangent. So by tangent line to circle theorem, we can say this is a tangent to circle P. Let's move to the next problem. That is finding the radius of a circle. Here we have been given a radius and a circle C. Our circle C is given here. We have to find how much is this. Few things are given. So I know if it is a radius, if it is a tangent, point of tangent C, B is the point of tangent C, so this is going to be a tangent. Tangent means the moment it is a tangent, I know it's supposed to make 90-degree angle. All right, so it's making 90-degree angle, so we can apply the Pythagorean theorem here. And we can write down, so here we have to figure out which ones are the, so this part and this part, they're the legs. So we have to square the legs, and which one is the hypotenuse? This is the hypotenuse. This whole thing is hypotenuse. But here in this case, this whole length is how much? That is basically, one part is 50, other part is r, so total is what? 50 plus r by segment addition postulate. So no worries even if it doesn't look normal, kind of just one number and expression. So AC square, first I have to write down AC square is BC square is AB square, sum of square of the legs. AC is 50 plus r plus 50 whole square is r square, one of the leg is r square, other is 80 square. Now we have to apply here for r plus 50, we have to apply a plus b whole square, and that's what? A square plus 2ab plus b square. We have to apply that. So we are just applied r changed to r square, 50 changed to 50 square, that is 2500, and 2 times r times 50 is what? 100r, and that's here in middle. So you just expanded it with the help of, so this is your a square, this is your b square, and this is your 2ab. You just plugged it in, and afterwards you just solve it. This is r square plus 80 square is 64 square. Then you simplify, you both sides subtract by r square, so you will be getting rid of this term and this term. R squares, you are having 100r is 3900, divide both sides by 100, you get r is 39. So you can see they are using the unit here, so it's going to be 39 feet for the answer. So let's move to the next problem. For next problem, our next question and the very last problem is this one, question number example 5. Using properties of tangents. Again, RS is a tangent, so RS means this is your tangent. I'm using T for an acronym for that. And then RT is a tangent. This is also a tangent, RT. Both are tangents for circle C. And from a point R, find the value of x. And we already know that external tangent congruence theorem says that if there is an external point and you draw tangents on the circle, not secant, sorry, then these two are going to be congruent. So it's the same thing, RS. So I could say that this RS and RT, they're going to be congruent. So RS is RT. So we plugged it in. RS is 28, RT is 3x plus 4. Subtract 4 from both sides. You get middle step is going to be 24 is 3x and x is what? 8. Your answer is 8. All right. Hope you get it. Any question, please leave in a comment box. Thank you so much. Stay healthy. Bye.